All of you keep heading. So next we are going to study conservation of angular momentum. So this is also very important concept for JEE mains and as well as NEET. So write it everybody. Conservation of angular momentum. JEE mains. Okay. So now, we have studied two formulas for conservation of angular momentum. Can anybody tell me what is the two formulas we studied? Everybody, please respond. All of you. Two formulas for angular momentum formulas. Yes, brothers. All right. So angular momentum L is equals to R into P. That is what linear momentum. And another formula which we have studied, angular momentum is equals to I into angular velocity. Am I right, guys? Please respond, all of you. So this is the formula which we have studied yesterday also. This is formula which is applicable for rigid bodies. And this one, let us make it now. So R cross linear momentum formula is what? M cross V. So I will take it MS outside. So R cross into V. So this R cross V only we can say it what, everybody? So M into V into R perpendicular. So this is the formula. It is only applicable for what mass? Everybody? It is for, actually it's a point mass. And this is for whole rigid body. Now, let us revise once again what is our concept of today's class is conservation of angular momentum. So it is related to class 9th only. So class 9th you might be studied conservation of momentum. It's angular momentum. So we are going to study linear momentum, just conservation of linear momentum or momentum. You might be remember, you used to study total momentum before collision. Total momentum before collision is equals to total momentum after collision. That is what you used to study. Am I right, everybody? So means initial momentum is equals to final momentum. Am I right, Pradosh? 9th class you might be studied. So before collision, conservation of linear momentum is equals to total momentum before collision. Before collision is equals to total momentum after collision. So what is the formula might be studied, everyone? So M1 U1 plus M2 U2, which is equals to M1 V1 plus, you all should involve in the class, M2 V1 plus M2 V2. So this is what is the conservation of momentum formula, linear momentum, which we have already studied in the 9th class. Yes, Mr. Saigarde, can you hear me? Mr. Rishi, Princey? That is what. Now, if you notice it here, so what will happen? All of you observe very carefully. Now we are going to study conservation of angular momentum. Forget about it and you tell me. If you remember, already we have studied force and laws of motion. So they are Newton's second law. According to Newton's second law, can you tell me what is Newton's second law? Anybody? According to Newton's second law, please. Everyone. So what is the Newton's second law? F is equals to, speak guys.
Constant acceleration.
Yes, that is brothers, but I said which is always true. Change in momentum divided by change in time period. That is the original formula, which is always true. 100% always true is this one. Am I right or wrong? So F is equals to MA is not true always. So change in momentum divided by change in time period is actually true. So now if I make it for, so we all knows that F force is a vector quantity. If I make it for integral like smaller particle, so dP by dt. So this is also it is. So F is equals to dP by dt. So this is the formula for what actually it is, a linear motion or rotational motion. It is for what motion, everybody? It is for linear motion. Understanding? So if it will comes to the rotational motion, so what else then? So let us go back to the now concepts, relation between linear and rotational motion. So if I take the linear motion, so we all knows the terms which we already studied from many times. I am teaching you. So linear motion, displacement; rotational motion, angular displacement, theta; linear velocity v, here angular velocity omega; here acceleration a, here what will happen? Angular acceleration. Speak guys, angular acceleration is what? Alpha, right or wrong? Here force F, here what will happen? force F here. Then what will happen? Torque tau. Here mass M. Here what will happen? Moment of inertia I. Here linear momentum P. Here linear momentum P. Here what will happen, everybody? Here respond. Angular momentum L. So we all knows that now. So what is velocity? Velocity means what, everybody? ds by dt. Same way, what is angular velocity? Speak loudly. d theta by dt. Understanding? So average velocity, what is velocity? dv by dt. What is the angular velocity? Sorry, angular acceleration? dw divided by dt. So we all know force is equals to ma. Same way, tau is equals to what, everybody? Tau is equals to m is yeah, I alpha. So the same way, momentum. So means m mass is equals to moment of inertia. So linear momentum is equals to mass into velocity. And what is the linear velocity? Yes. Linear momentum, everybody. Linear momentum is mass into velocity. Angular momentum means what, everybody? I into angular velocity. Are you understanding, everybody? So that is what is the relation which we already studied between the linear and rotational motion. Now, according to Newton's second law, so if you observe very carefully, if it is the linear, F is equals to dp by d theta. So we know that this F is also internal force or external force, everybody. Internal force does not change the momentum. Only what force we can change, everybody? F external. Only external force only will changes the momentum. So the force, that is why we'll write F external is equals to dp divided by dt, because internal forces cannot change the what, everybody? Only motion objects will be exerting what? Objects which are in motion only will produce the momentum. So the objects which is in state of rest, they will never create the momentum. So that is why internal force not change the what? Understanding, everybody? It will not able to change the, please respond, not able to change the momentum. Only F external. So external force is equals to dp by dt. This is for linear. Now same thing apply for rotational, and can you tell me what will happen? That is only called as conservation of momentum. So you can angular momentum. So for this rotational, what will happen, everybody? Here force, then rotational, what will happen? Here it is there, just now I have written. Here it is a force, means here what will happen, guys? It will become tau. Understanding? Torque. So torque is equals to, here linear momentum. Then here what will happen? Angular momentum divided by angular time. So time. So now it is also same. So tau is equals to dl divided by d theta. So dt. So this is what you have to remember. And also we all knows the relation. So why this relation we will study. Okay. So this is what you have to remember. So now if you notice that, what does it mean? I have written two things now. So F here also, tau internal or external, everybody? Tau external only. So internal torque is never be it is. Only the external torque is equals to angular displacement, angular momentum divided by dt. Angular, that is what, dl by dt. So what does it mean here? So that is very important. So angular momentum will not change in the direction as that of torque. So we have to remember always the direction of torque. What do you mean by that? I'm writing here. Direction of torque and angular momentum both will be in the same. Same way, F is equals to, I am writing dp divided by dt. What does it mean? The direction of force and direction of momentum is in same direction. So that is what we used to call as, everybody, what we used to say? Linear momentum and as well as rotational. That is what conserve angular momentum. So now if you notice it, so let us take this formula. If I take F external is equals to 0, F external means external force is 0, then dp also will become what, guys, everybody? Change in dp. What do you mean by dp? Change in momentum or change in momentum, everybody? Please respond. Change in momentum. Understanding? So change in momentum. So if external force is 0, so what will happen, guys? What is the change in momentum? Change in momentum also will become what? Please respond. Change in momentum become 0. So means in the sense of P is remains constant or varies? P is remains constant or varies? Whatever the momentum of the body, it is remains constant. So means in the sense of what will happen for entire system? If I consider entire system, There is no change in momentum. Means what will happen, guys? Initial momentum is equals to, please speak loudly, initial momentum is equals to final momentum for entire system. So that is only called as what? Initial momentum is equals to final momentum. That's what we are studying. Initial momentum is equals to final momentum. That is only called as what? Conservation of momentum.
Linear.
Understand it? So conservation of momentum. So when the initial momentum is equals to final momentum, everybody, when a conservation, the external force applied force will become zero, then what will happen, everybody? So the initial momentum is equals to final momentum. Why? There is no external force is applied. There is no change in the momentum. So that there is no change in the momentum means momentum remains constant or varies, everybody?
Constant.
Yes, remains constant. So that is what. So if the momentum remains constant, what will happen, everyone? So initial momentum is equals to final momentum. Means momentum is conserved or not? Momentum remains constant. Means conservation of momentum. That is only called as conservation of momentum. I hope you all understand. Everybody clear? Yes, please. Pradosh, Naren, understand, Naren? Yes? Sai Karthik?
Yes, sir.
Yeah. So that is what you have to remember. Now, this is for what actually linear momentum, but what we are studying, conservation of angular momentum. So that is very important. Okay. So now here you write it, please, before it, whatever it is, the force or the F or torque, whatever it is. So what is this indicating? Both are same direction, means angular momentum. If it is linear momentum, angular momentum will change the direction. Will change direction as that of torque. Which torque? Internal torque or external torque? Everybody. It is external torque. Do you understand, everyone? Please respond, guys. Everybody. So the same thing. Now let us exercise. So coming to the angular momentum. So if I take angular momentum, what is the formula we have written? Tau is equals to dl divided by d theta. So here also same. Tau means internal torque or external torque? Yes, please. Internal or external torque?
External, sir.
External torque. Only external torque will be applicable. So what will happen, everyone? Everybody? So it is actually external torque. So what will happen, all of you? So external torque, if external torque will become zero, so what will happen, guys? There is no change in torque.
Also
So external torque is zero, means change in angular momentum also will become what? Everybody? Zero. Means in the sense of what? Angular momentum remains constant. Remains constant. So if angular momentum is remains constant, means what will happen, everybody? Yes, please.
Initial torque is equal to
So
final.
external is equals to zero, means in the sense of what? Initial angular momentum is equals to final angular momentum. So means in the sense of momentum is what? What we used to call? That is only we used to called as conservation of angular momentum. Means there is no change in momentum. Initial momentum is equals to final momentum. So angular momentum. That is what we used to call as. So entire system, the angular momentum is remains constant when external torque will become zero. If there is no external torque, then the total angular momentum of a system is remains constant. So means in the sense of momentum is conserved. That is only we can say conservation of angular momentum. So all of you remember when the conservation of angular momentum will happen, everybody, when external torque, applied torque will become how much, everybody? Zero. Then what will happen? Anyhow, there is no use of what torque? There is no change in the angular momentum by the internal torque. Internal torque is no use for changing the angular momentum. So that's what. So all of you observe very carefully. If tau or the torque about any axis will become zero. Which torque actually it is? External torque. Understanding? So about any axis, if torque is zero, all of you remember about that axis, angular momentum about that axis is remains zero or constant? Anybody? It is remains constant. Are you clear, everyone? So that is, you have to remember it. So whenever tau, the external torque, very important. If the torque about any axis is 0, then the angular momentum about that particular axis is remains constant. So very, very important one. I hope you all understand. Everybody clear? So what is the conservation of angular momentum formula? Tau is equals to dl divided by dt. So let us make the proof now. So it is according to which law? Newton's? All of you. It is according to which law, guys? Newton's second law. So let us make the proof now so that you all will understand. So keep adding, everybody. Proof. Okay. So we all knows that. What is the second formula of angular momentum? Anybody can tell? L is equals to, speak loudly, everyone. L is equals to I into omega. Okay.
Angular velocity.
Yeah. So apply the integral differentiation. So dl by d theta with respect to time, which is equals to, we all knows that I is remains constant. So you will apply d omega divided by d theta. Any doubt for anybody? You can tell me. So I is remains what? Inertia is remains what? Yes,
Constant.
please. Constant. Because inertia
Constant.
never change for everybody. Now, dl divided by d theta, which is equals to I into. So we all knows that dw by d theta, which is equals to something. Anybody can tell? Just now I have studied. I have taught you
Angular acceleration.
angular acceleration. Understanding, everyone? So that's all it is. So I'll write instead of dw by d theta, which is equals to angular acceleration. That's all. And we all knows that torque is equals to, what is the formula, brothers? I into
Angular acceleration.
So torque is equals to dl divided by dt. That is only the proof for conservation of angular momentum. So the direction of torque is always same as the direction of angular momentum. So that is what you have to remember. So this is according to which law, everybody? According to Newton's second law. Okay. So according to the Newton's second law, angular torque is equals to angular momentum divided by time taken. That is what? dl divided by dt. So anybody having any doubt, you can ask me. Are you clear, everybody? I hope you all understand. So this is only called as conservation of angular momentum. Any doubt, guys? Please respond. Are you clear?
Understood.
Yeah. So this is what we used to call conservation of momentum. Now observe very carefully. So now onwards, let us write first question now. So you all of you observe what is the relationship between angular momentum and angular velocity. Let us discuss it now. So keep it in mind. Now itself I am saying you angular momentum is inversely proportional to angular velocity. Means if suppose for example angular momentum increases, angular velocity decreases. Angular momentum decreases, angular velocity increases. Just have a glance so that when you are solving, you will all understand it. Clear, everybody? Now, for example, all of you observe very carefully. There is a chota boy, chota man. So who is doing exercise and who is standing on the platform. So this is a platform. Let me take it now. So if I take a platform now, he is stretching his hands in both the sides and he is holding the dumbbells. Both hands he is holding the what? Everybody? Please respond. Dumbbells. Are you understanding? Now imagine this is the axis of rotation which is exactly passing through this middle. Now, so there is a force which is acting downward direction. What is the force of the body which is acting downward direction? Everybody, all people knows. Mass of the body is m and about the g. So now, this imagine about this axis of rotation, angular velocity is omega. Now his hands are touched maximum distance. Means the distance from the axis of rotation we used to call something. Anybody, what is that called as? Speak loudly, guys. Which is called as R. Are understanding? Yes, please respond, Ra. So that is what
Yes,
we say dumbbell. Now, all of you observe. So the torque across this axis of rotation, what will happen? Torque across his weights, which is equals to what will happen? 0. So means in the sense of, you all observe very carefully. So what is the I formula? Can anybody tell me? I formula. I is equals to, yes, please. Speak loudly, guys. I is equals to what is the formula? Hey, inertia formula, ra. That's what I'm asking. Inertia formula. Nobody knows, huh? You say only L, bro. Inertia formula, please. Ma? What you have written, at least you can see. I is equals to what? That's what we are doing now. So we all knows you want to write. So we all knows L is
L by omega.
yeah, I omega. So I is equals to what? Everybody, L by omega, whatever it is. Okay. So what is the relationship between I and omega? Check it, everybody. Just now here I have written correct. What is that? Directly proportional,
Inversely proportional.
That is what. Understand? So I is equals to L by omega. So I and omega is inversely proportional to each other. So now try to understand. So about its axis. Now this man dumbbells are very far away from its axis of rotation. Now the same man about the axis of rotation is passing, guys. All of you observe in the same platform. Now the dumbbells are came closer to his. Understand, brothers? So now dumbbells are came closer to his body. Now, if you notice it, R is less or more? R value. R value is small or less? All of you, please respond. R value is less or more? Less. So both the cases, same person. Now, if you observe very carefully, when R is greater, I is also increases. So R value increases, I value increases. If I increases, what will decreases? Everybody. Angular velocity will decreases. Clear? Now here R is decreasing. So R is decreasing. So means angular inertia is also will decreases, but angular velocity will increases. I hope you all understanding, everybody. So for example, let us take now. If I make it all of you, if it is a for R value. So if for example I is equals to 10, W is equals to angular velocity is equals to 5, then L is equals to I into omega, which is equals to 50 angular velocity. Sorry, angular momentum. So now, if it comes to this body when he is closer, so if you notice it, I is equals to maybe 2 and omega is equals to angular velocity is equals to 25. Now, if you calculate also I into omega, what is the answer? Everybody. Yes, please. Angular velocity is what? G is same. So means in the sense of angular initial momentum is equals to final angular momentum. So that's all it is. Means what is the formula? If I take initial momentum, let me take I1 omega 1 is equals to I2 omega 2. So this is the basic formula for conservation of angular momentum. So you can calculate by using this simple numericals and all. We can use this formula to calculate it. Anybody having any doubt, you can ask me. So this is what linear momentum, angular momentum before and angular is equals to angular momentum after. That is what you have to remember. I hope you all understanding. Everybody clear? So you can see when the hands are far away from him. So by the time inertia increases, okay. So angular velocity decreases. But here when he will bring the dumbbells closer to his body, R value decreases, so that I also decreasing, but angular velocity will increase. That is the relation which you have to remember. I hope you all understanding, Mr. Narayan. Brothers, clear? Okay.
Yes, sir.
For example, you can see. So what will happen? For example, you can see there is a tall building where down you have a swimming pool. Okay. So now how many of you are know swimming? I think many of you know swimming. You can see when you are swimming, if you want to jump from a long like a tall building, so you can see you'll make the flips. Am I right, everybody? You all people make the flips or not? Please respond. All of you.
Yes, sir.
Yes. So a person will start jumping and rotating, revolving, and finally he will fall into the water. So if he jumps, what will happen? You can see. Of course, his axis of rotation. So means if person will started taking closer, the head will come closer to the neck. So he's a diver actually. So diving. So when he will flip off, so what will happen, everybody? So at certain stage, he will completely turn up into, like you can see, whole body will come closer. Am I right, guys? A flip, when he make the flip, please respond, all of you. Yes, please, all of you. So now you can see here from the axis of rotation, if you say from the center, R value is maybe greater. So when he is jumping and making the flips, so what will happen? R value keep on decreasing, increases, everybody. Yes, please. From the axis of rotation. Everybody respond, the center point is same. So when he is keep on flipping, so you can see now it is very far. Now it is rotating head coming closer, next turning, next turning, next turning, like that. He'll be keep on making the flips. So he's keep on making the flips means R value keep on decreases. So R value decreases means I is also what will happen? I also decreases, but what will increases? Angular velocity will increases. Linear, yeah, inertia of a body will decreases. So, but you can see if angular inertia is keep on decreases, then number of flips will increases or decreases. Angular, it is number of flips will increases or decreases. Please respond. That is what rotations. All of you. So when he is coming down, please respond. Number of rotations will increases or decreases. Everybody. So number of rotations will increases. Clear? So number of rotations will increase, but what will happen? That's what. First, initially, now imagine this is the axis of rotation for a person. Now, when he turns one first flip, this head is coming closer to the axis of rotation, but still axis of rotation is here. So like that, he is making a flip around it, or he is making a rounds like flipping. So number of rotations. So always the body is coming closer to the center. That is what R is keep on decreasing. So R is decreasing means I inertia also decreases. So what will increases? Everybody. Angular, speak guys. Angular velocity increases. So that is what is about this one. Now let us solve. We'll with the help of this one small sum we'll solve so that you all understand it. So put it as sum now. So write the question. A diver with MY, a diver with MY means what? Moment of inertia of 6 kg meter square. 6 kg meter square has omega is equals to 2 radians per second. What is omega? Everybody, you should speak, then only I can. What is omega? Angular
velocity.
Velocity. So angular velocity is equals to, so we all people already studied. So angular velocity you should learn. Angular velocity omega. Okay, everybody clear? I hope no confusion for anybody. So now question is that my and angular velocity is 2 radians per second. He folds his body and reduces my moment of inertia to 5 kg meter square. Okay, find new angular velocity. That is what is the target. Now I'm giving just 2 minutes time, so anybody can, even 2 minutes not required. If your concept is clear, over. So torque about the center of mass, that is what external, which is equals to what? Everybody, external is equals to what? Please respond. 0. If it is torque is 0, so we all knows that initial angular momentum is equals to final angular momentum. So initial angular momentum I1 omega 1, final angular momentum I2 omega 2.
I2.
We all knows I1 is 6, omega 1 is 2, I2 is 5, and omega 2 is omega 2. We want to find that only. So omega 2 is equals to, what is the answer? 12 divided by 5, which is equals to 2.5 radians per 2.5 radians per second. So that is what you have to remember. I hope you all understanding, guys. Please respond, guys. Okay, all of you. So now you all stand in front of now you are sitting in front of the computer or phone or whatever it is. Now stretch your hands both the sides, everybody. Stretch maximum. Don't fold it. Stretch maximum, all of you. Have you all done? Please respond, everybody. Yes. Now, from that point, you keep on raise your hands vertically upwards. Raise your hands like they have to touch both the sides of your ear. Okay. So like that. Now you tell me. So R value keep on decreases or increases. When you fold your hands, I value keep on decreases or increases. Suppose you can see you are doing an exercise. For example, you kept your hands like this. Now you started folding. So you just started folding means your hands are coming closer, legs also coming closer, and hands are okay, everybody. So if the hands, you can see here it is stretched. Now here it is folding. So when it is folding, all of you remember I value keep on decreases and what will happen? Angular velocity will keep on increases. That is what I want to say. So please remember that, everybody. When we are folding the hands, understanding all of you? So inertia will keep on decreases and angular velocity keep on increases. So please learn it. Okay. Understand for those everything? So this is the concept which we are studying now. So now, based upon this, there is a question. Let us solve the question. So which is actually asked in JEE 2004 actually. So based upon exact concept. So you all can find it fastly, okay? So it is meeting ends also, you can join and find it. So a boy is standing on a platform which is free to rotate about an axis passing through its center. The kinetic energy of a boy and platform both together, because he's rotating in this, like you can see, massive, which is actually okay. Imagine that there is a round table, you all can see that. Do all people knows rotating table? So a boy is here. Okay, so whose kinetic energy is how much, guys? Everybody? Yes, please. Whose kinetic energy is what? K. Clear? Understanding?
Yes.
So boy as well as about the axis. That is the meaning of it. Now, they're saying if the boy stretches his hands, means what does it mean? Initial case, he is folding his hands up, stretching his hands up. If he stretches, that is the question. Write it. If the boy stretches his hands, means he is opening, R value increase or decrease, Pradosh, and doubles MY, moment of inertia, find new kinetic energy. Find what, everybody? New kinetic energy. Means initially he is folding the hands or not. He is stretching in the second cases, so that it doubles the MY. Means moment of inertia become what, everybody? Speak loudly, guys. Moment of inertia become what? Doubles. Okay. So means about the same axis of rotation. So now what is happening about this? Now he stretched his hands. So stretched his hands means we all